Today's problem is submitted by a viewer, and it says, given that the roots of the equation x cubed plus px squared plus qx plus r equals 0 are three consecutive terms of an arithmetic progression, show that 3p cubed plus 27r is equal to 9pq. Okay. So I'm just going to write out exactly the information that we're given and see if I can manipulate, I'm going to write out the information we're given in terms of mathematical statements and see if I can manipulate the resulting equations to end up with the identity that we're trying to prove. I've never seen a question exactly like this before, so I don't really know where things are going, but hopefully it just sort of comes into place. So we're given this. This equation will have three roots, possibly with multiplicity, but we're told that they are terms in an arithmetic progression. So let's suppose the three terms in the arithmetic progression are A1, well, no, let's just do it like this. A plus D, and A plus 2D. So one thing I'm thinking is to take these three and substitute them in there one by one. That was my first thought, and then just sort of, we'll have a system of equations. Maybe we can write down relations that have to hold between things, but I don't actually think, a little bit more thought, I don't think that's the best way of writing it, or by going through this problem. Instead, what I'll do is I'll write this cubic in a factorized form where I know what these are the three roots are, and then just expand and see if I can, by grouping powers of x, maybe I come up with a relation. So that's going to be my first attempt, but we'll come back to this other thing, if it doesn't work. So x minus a times x minus a minus d times x minus a minus 2d. I'm going to expand this and set it equal to that. Okay, well, we have this whole expanded thing here, and so what I need is negative 3a plus 3d should be equal to p. I have 2a plus d, a plus 2d plus a times a plus d is equal to q, and negative a plus d, a plus 2d must be equal to r. Now I suppose, so this must hold. P, Q, and R must satisfy this. So I suppose what I could do is, now that I have expressions for P, Q, and R in terms of A and D, is just verify that the identity that's given to us has to hold. I think I'll do that. I'll just do it that way. It's a little bit tedious and messy, but we'll work through it. Okay. Is there a way that I can simplify this for myself? I mean, maybe I can expand this term in Q to make this a little bit nicer. I'll do it in a few steps. Okay, so the identity we have is 2p cubed plus 27r is equal to 9pq. So let's start with the left-hand side only. I have 2 times 3a plus 3d cubed with a negative sign plus 27 times negative a plus d, a plus 2d. Honestly, it might be easier to. Nah, let's. I'll just do it. I'll just expand this whole thing. Okay, so there's the left-hand side, 2p cubed plus 27r. I hope I didn't make any algebra mistakes. Let me check my work quickly in my head. I do have a mistake. So these two things need to be multiplied by 3. Let me just write this as 27. 3 times 27. 3 times 27. And so I have a 3 here and a 3 here. So that affects the a squared d. So a squared d should be 6, 9. And AD squared should be 6, 7, 8. Unless I also made mistakes on the other side. Okay, I hope this is correct. Now let's compute the other side. 9pq. 9, well, p is equal to negative 3a plus 3d cubed. Wait, what is it? P is 3a plus 3d, yeah. And q, 3a cubed plus 6ad plus 2d squared. This looks strange, the fact that there's no way that's correct. a squared. Let me verify that I did this correctly then before moving on. Okay. And expanding this whole thing. So this gives us negative 27 a plus d, 3a squared plus 6ad plus 2d squared. And is this the same as what we had? Negative 27, 3a cubed, 9a squared d, 8ad squared. Uh-oh, I have a 2d cubed here, but only 1 up here. Oh, that's clearly a mistake. I clearly missed that factor of 2 there. Okay, and so we end up with the same thing in both expressions. Not sure if this was the best way to do it. It was straightforward, but very tedious. A lot of room for potential arithmetic or algebra mistakes. And I'm not sure how my other approach would have gone. I don't have good hopes, right? Like substituting these 3 numbers into here will give 3 equations relating 5 unknowns. And you would have to somehow manipulate those equations, I guess, find ways of, and not only that, but you know, it would only be linear in P. All those equations would just have a P in it, and but the identity we're trying to prove has a P cubed. So yeah, I don't think it would be an easy way about to do that. So I think this is a better way of doing it, more straightforward certainly, but maybe there's something that someone else can come up with, another idea where you don't have to do so much algebra and so on, but it works. Thanks for the submission, and thanks for watching.